What is good, you guys? I'm Jaideep and welcome back to the channel. So before we start today's video, I hope all of you are well. You're following the COVID guidelines, you're wearing a mask, you're not stepping out unnecessarily and contributing indirectly or directly to the spread of this virus. Together, we need to work to defeat and end this. It's been on for a while. Everyone, is kind of bored, frustrated. You can put whatever, you can use whatever word you want to describe the situation, but it is what it is. And if we need to work together to stop the spread. So as part of this, I urge everyone to follow the COVID guidelines, wear a mask, use a hand sanitizer, wash your hands often. It's a very basic ask, and I think everyone can do it. So with that being said, let's get back to the data types such as list, dictionaries, tuple. It is time to move on to the collections module, which contains some specialized implementation of this which contains the specialized implementation of some of the container data type. Well, and the first in line is the counter. So what the counter does is it actually provides a counter over the given input. For example, I have two strings over here which contain some random characters, and then this is a sentence which contains some repetitive occurrences of how do you say, which contains some repetitive occurrences of a word or a particular letter as well. If you want to initialize a counter over this, what you can simply do is you can call the counter class and pass the string input to it. And if you see the input, see the output of C, then what it does is it provides the occurrences of each the count of number of occurrences of each and every one of this character. If we do something like and I do a pretty print of this, well, not exactly this, but you can do that as well, but just let's split it instead of. And if I now do a pretty print of this, what it gives is the number of times each and every either a letter or a word that the sentence contains. So if you see in this sentence, I occurred twice, then am occurred twice, and then rest of the things occurs only once, and it gives a counter object over it. This is a nice handy one which you can use for text processing applications as such. To go along with this, the counter class also provides certain methods which you can use to analyze this data further. So if I print this d variable again, and I want to see the most commonly occurring what do you say, character in this, what I can simply do is d dot most underscore common and say the most common occurring 1. If you want the most common occurring 2, then it will give the 2 most common occurring. If you give it as input 3, then the 3 most common occurring. So this is how it will work. There is another counter, c is equal to counter of say I, because this contains I, and let's do am as well. How is it am and dot split, and now see I has one occurrence of this counter has one occurrence of I and one occurrence of m. And if we do something like c plus d, let's pretty print it. Now I is 3, am is 3. So if you see here, I was 2, I was 2, I am was 2, here I've added one more occurrence. Similarly, you can do c minus d as well. It's all about the counter class which is provided as part of collections. The next in line is the Deque, which is a shorthand for the double-ended queue. Now, in our list tutorial, we saw that the list can be very well used to implement stacks and queues. In order to insert the element at the starting of the list, you would use the insert method which is available and pass an index to it, and then the element which is followed. But this has a higher overhead, and it is not optimized for this purpose. What happens in a Deque instead is it has specialized method called as append left. That is, you want to append on the left side of this Deque, and you can simply do a z. And so if we now compare A and D, then it has the same number of elements, right? And this is much more optimized for this purpose. Similarly, if we want to append to the right, then what we will do is a dot insert or just a dot append, and say we append element G. A is now this. A contains the element A now contains the element G at the last. Similarly, D dot append, and you want to insert the element G, and then A and D are still similar. So this append operation is similar, but the append left operation is specialized in the Deque. Similar to the append, you have the pop left, and it pops the element which is on the left side. So you see implementation of a queue and implementation of queues and stacks are much more optimized using a Deque. So if you want to implement a system which relies on the stack and the queue database, not the database but stack on the queue data structures, then Deques are much more optimized for that. Similar to these methods, there are other methods such as you can rotate it. If I d dot rotate 1, and if you now print D, what has happened is it has rotated the elements, so it has shifted the elements to the right. So Z is so Z is now so sorry, we removed Z, but A is now rotated one place to the right, and the element which is at the right has come into the beginning. Similarly, you can do a rotate of -1, and it would rotate counterclockwise. Let me print D, and if you see, it's gone back original. So from left to right, so that is how the rotate works. So this is how Deques can be used more effectively than lists to implement stacks and queues. One thing to cover about Deques is they are fixed length. You can pass in a maximum. This is called as the max length, and you can pass it as an arbitrary parameter. This is optional. If it is not given, then there's no max length, and you can have a list of Deque of any length. Now if you try to append an element, now let's just see the Deque rather, and it has 1 2 3 4 5 elements because the max length was 5. Now if you try to append an element, no matter where you try to append it, left, right, you try to append an element G here, and if you see, the first element which is inserted was discarded, and at any given time the Deque will only contain 5 elements only. So this is another thing. So this is another point to know about Deques, that they have this arbitrary max length parameter, and it is totally optional. You can ignore it, and then it is defaulted to none. The next in line, and probably the most useful of these lot, are the name tuples. The name tuples are similar to tuples, but they differ in the aspect that they allow assigning of names to the individual elements of the tuple in addition to the indexes. So a very good use case of them is creating classes where you don't want those classes to have any methods as such. So for example, what I've taken here is I want to initialize a class which represents the deck of cards or a particular card. So if you are big on cards, who plays cards a lot, which I believe is everyone, then every deck of cards has a suit and the rank. So I've initialized a name tuple and assigned it back to variable. And using this variable, then I've created a particular card which is which is a queen of hearts. And then in addition to accessing it by index, then the elements can be accessed using the names as well. So if you see this, the two names were assigned, suit and rank, then I can assign these elements using the suit and rank as well. So this is one use case. A more common or a general purpose use case which you can relate to is, suppose you want to store an employee data, and the fields of the record are fixed. Then you can create a name tuple, and each record will be named as employee record, and it has the following 3 attributes. And then the data can be created using this particular variable, and this would now be a tuple, and you can access the elements using the name dot department. I should have named it department. So this is how name tuples are used. The name tuple also provides some inbuilt handy methods which you can use to create the data as well. Suppose I have a list which contains the data of an employee, then I can use the make method, and the data will be translated to the name tuple type which we created earlier. Also, if you want to view this data as a dictionary, then you can use the asDict method, and it will return this data as a dictionary. Also, there is a replace where I've changed my department and moved myself from IT to HR. So my department is now HR. So these are a few inbuilt handy methods which are also available, which make your life a bit easier. So the next in line are the default dictionaries, and then as the name suggests, default dictionaries allow you to assign a default value if the key is not present. Now in case of a normal dictionary, if you try to access a key which doesn't exist in the dictionary, then you'll get a key error. But in case of a default dictionary, it will assign a default value. Now this default dictionary is currently blank, but if you try to access a key, then what it will do is it will assign a default value. If you try to assign a meaningful value, then that is not an issue. This would be okay. But if you try to assign if you try to access a key which doesn't exist, then it will be assigned a default value, and that key will now be present as a part of the dictionary. You can also supply a more meaningful value using a function. Say try to assign a value a, access a key a rather, then if I try to let's just print c, you see a has been assigned this default value as part of this function. So what default dictionary will do is it will call the function using this default value and then assign it. If you try to assign a meaningful value, then that should not be an issue. And if we now try, well, I forget to print it, and but if you try to assign a meaningful value, this is okay. But in case the key doesn't exist and you do not supply any value, a default value will be supplied as part of this function. So this is how default dictionaries are useful. So on a closing note, default dictionaries provide default values, but the same functionality is available as a part of dictionaries as well. So if you do something like d.set default, say I want to add a new key d and I want to give it a default. If it doesn't exist, I want to give it a default value 100. Then this should work as well. But the whole point of this collections module to exist is they are specifically optimized for certain purposes. Hence instead of using say something as a set default on a large dictionary, you can very well use the default dictionary, because it's the whole idea of giving the collections module. So that is it for the collection module, which contains certain specialized implementation of the existing data types. For example, you can use the Deque, where you have implementations of say a list, say a stack or a queue. The name tuple can be used wherein you need name tuples, or wherever you have to create classes with certain attributes but which do not have any methods, and so on.